Hello, sorry. I need to talk at some point, obviously. Connor, Harand, hello. Julian, hello. Maybe I'll just do a silent stream, just not talk, not acknowledge anyone, just code straight 2 hours, just see what we do. Moose, hello. John, hello. Yeah, I have only a rough plan for today. It's been quite a long weekend. My brain is already frazzled, and I've quite an early start tomorrow, so I think today's gonna be more chill. Let's just go back, review some of the code, make some quality of life changes, fix up some stuff, yada yada yada. Just see what we get to. It's gonna be not vibe coding, obviously, but like gonna go with the flow coding. Exciting. Good. Best of luck. Queco, hello. I think Queco also got first. Congratulations. Governor, shiny shoes, Governor. Okie dokie. Right. I guess we'll get started in a minute. So I do have somewhere. Oh no, my mouse is locked to this. I'll check in a second. Slow as in like not a lot of people, or slow as in like slow updating? Nano, hello. It takes a while for people to roll in. Like if you look at the charts, it sort of builds up slowly, and then I feel quite fortunate that most people hang around. Mr. Steak, hello. Okay, let's quit out of this. And let's put me in the box, the circle. So I have a rough list of like laundry list of things to do. I did have it up, but I've lost it. Where is it? Here we go. So need to remove some variables. I want to make sure the GPU buffers have names, refactor some of the buffer usage. We had some error warning that I had to remove for STBI. Going to see if we can maybe figure that out. I want to do ImGui docking. I want to preview the frame, but then I want to do a load of ImGui stuff basically. So there's quite a lot to kind of get through today. I think we're just going to see what we can get through. At the moment, I'm going to keep everything hard coded. I feel like am I slightly off kilter here. I'm going to keep everything hard coded and then have some sort of YAML scene-based descriptor at some point. I probably need to have like a scene serializer, so we can just, as we make changes, they just get serialized to disk, and then when you restart, it just pulls it back up. That's like way down the future though. For now, like we won't need that until we actually start to try and construct a level. At the moment, we're still building out the early tech, so it doesn't really, like, everything is ephemeral anyway, so it doesn't really matter. That's kind of my view on it. Again, taking the view that can we solve the problems that we have like right here, right now? What's this? What's my tool? Okay, apparently maybe small chance I'm not seeing Twitch comments, but that might be okay. As in, like, that's not okay, but I think that might be resolved now. Okay. Oh, you're here. That's fine. You're back. It's just a way of forcing engagement. Every now and then I'm like, I can't see any comments, and they all flood in. Okay, so the first thing I want to do is, someone pointed this out in a comment, and it's totally valid. This base variable is no longer used, right? Like, it's all weird. It's just bookkeeping that we no longer need since Mr. Steak helped fix the command buffer issue. So I think we can just like sack all this off, right? Which also means now this becomes a stateless lambda because it's got no capture list, which opens up additional opportunities for optimization. couldn't tell you exactly what they are, but it literally is just a call operator now. So it might even be able to be inlined. I'm not sure, but there's definitely certain optimization paths the compiler can take when you have a stateless Lambda. So it's just, I guess it's going to be a lot of like making some changes, checking it still runs, making some more changes. Looks good to me. Oh, the only other thing I fixed off stream is I updated the Docker file to make it a little bit, well, added some unnecessary white space. That's on me. Tidied up the Docker file, updated the git ignore, and basically I made the debugger work, so I can now use VS Code to debug this and have symbols and have pretty printing and all that. So that should mean if we do come across any issues, we have like a better tool for solving those. So we can now just like remove unused var. I did not know the GitHub Actions lets use bash on Windows runners. So does it have, how does that work? Does it have like a Windows implementation of bash then? Or is it the whole thing driven via Linux and then it just farms out specific bits to Windows? Git bash, nice, classic. At the moment, I'm not handling culling. I could do a Z depth prepass, which I guess is kind of culling. We had frustum culling in the last project. I may bring that back. I haven't decided yet. It really depends on the bottleneck. I kind of want to keep the code as simple as possible. So if I don't need frustum culling, like if it's not going to make a massive difference to the end result, then I won't bother adding it. So it's one of those things we can add later, but I don't want to complicate the renderer now when there's a lot of other things we need to do to complicate it first. Okay, so that's one tick done. Oh, someone also pointed out that, so potentially the reason that I need vec4 here, even though the frame buffer is only 3 components, is because blending mode is enabled, which means the OpenGL state machine kind of forces an alpha channel on it for you. So what I need to do is try disabling blending mode and then seeing if I can make those vec3s. So that was something someone pointed out, and I would like to try that. Also, I did install the LSP, so now I have like autocomplete, which is nice. I don't have like red squiggly line. There's no like ClangD equivalent, but I do have now autocomplete, and it works quite nicely even with the custom types as well. So you can do like material data 0 dot, and then get the members or the fields. So that's quite nice. Okay, fine. So what's the next thing? So GPU buffer store name. So let's have a look at all our buffer types. So when it says store name, I think this means this should expose a name and then be able to retrieve that. Yeah, I guess I don't know what it would compile it with. Like, isn't there some SpearV tooling or something? I guess I don't have that set up. I don't, because you can even on OpenGL you can pre-compile your shaders, right, and then just upload some sort of SpearV or whatever it is bytecode. It might be an extension. I'm not sure. I think I just want to just have the string name here, right, and then it'd be like auto name const the string view. Help. So I don't need that. I don't need that. I just turn this up as we go along. Yeah, I mean, I've got no plans of doing that because I just, like, we're not going to have so many shaders that runtime computing, like compiling them at the beginning of the program, is going to be an issue. But it's kind of interesting. So if we open up the buffer class. Yeah, I mean, I get that, but like, I think again, because compilation is so quick at the start of the program, we find out pretty quickly anyway, and it means I don't have to complicate the build system or have any dependencies on that. So for me, I'm kind of happy to keep it as is, but I do understand your point. Okay, so I'm just going to shove the name in the name hole. So single player, because whilst we've only started this project, right? And I kind of would like this project to be about 12 months like the last one. So I think in 12 months we can build out the tech for an FPS, right? Run around, shoot some stuff. I've kind of gone through the laundry list of stuff we want before. Because it's basically impossible for me to not already be thinking about what comes afterwards, I think the next one will be multiplayer. Like I kind of like each project, assuming I do one project a year, right? I'd like each one to have some sort of interesting step up from the one before. So the step up in this one is the rendering tech, plus building all the lessons we learned from before. So, but the main difference I think in this will be the rendering tech. So I think the main difference in the next one will probably keep the deferred renderer and then do multiplayer. And then the one after that, I mean, it could be anything. It could be compute shader, kind of forward plus renderer. Could be anything. So I think doing multiplayer for this is too much. But I'd be tempted to try multiplayer at some point. I would really like to do some networking code. I think, but what I would really like to do is wait for executors and stuff like that to kind of have some decent implementation in the standard, not as a library, and then because I need to learn that, so it might be a good excuse in a year if they've got it to figure out that, because I'd want to do most of the socket programming from scratch. Anyway, that should be that. So I think that should just work, because it's whether we need to, we might need to percolate that out actually, because we have a couple of higher level buffer classes. So we've got the persistent buffer, right? Oh, so this should have a name as well, because this is slightly different. This is the coherent bit one. So this should have a similar API. So this should have a std string name. Again, this is part of this is the main thrust of today's stream. It's just to go through and fix some stuff that we missed before, make a few changes. Because I think the next thing to do is going to be model loading and then start building out something that we can actually see. Cosant. Won't that need Cstra? No, that should need string view though. Streaming is very strange. I really enjoy it, but it is I came to the conclusion quite early on that I am basically here for your entertainment, and part of that is making progress. So I do have to make concessions, which is why it's nice every now and then to like a catch-up stream like this, a bit more lightweight, kind of go through some questions stuff. But yeah, I do kind of get your point. Like, is it entertaining if nothing happens for 3 hours straight? Maybe not. So yeah, streaming development is a very strange one. It's very much not. This is not how I would stream. This is not how I would develop normally, I don't think. Although you are getting my sort of raw conscious thoughts, which all I'm saying to you now is probably what I would be thinking if I was just doing this by myself. I don't want. So the question is, right, should this be a string view if the name are always literals? feel that that is a bear trap, and like I think they are probably always string literals now, but in the future when we construct stuff out of low like file data or embedded resources, they might not always be, and it's I would rather just pay the price of a copy of a allocation and a copy now and not have to worry about it. I don't like storing string view in classes unless I can be absolutely guaranteed that it is a non-owning class, whereas this class represents a buffer and I think it should own the name of it. But yeah, I get your point, but for me, I don't think it's worth the potential misery down the line. Is streaming mentally taxing for me? Well, great question. Is streaming mentally taxing? A little bit, like, because I'm kind of cognizant of the fact that I need to be writing code and I need to be making progress and I need to be fixing bugs because I write loads of bugs, and then I need to be kind of engaging with the chat and answering questions, and there's quite a lot going on. But for me, once I get in a flow with it, it's not too bad. I find the exhaustion definitely comes after the stream when I sit down and my brain is just racing at like 1,000 miles an hour. Like, oh, why did I not do that? Why did I not explain it like this? Why did I? Do you know what I mean? There's a weird introspection for me after the stream. But other than that, I've been doing it for a couple of years now, streaming, and I'm kind of in the flow of it. Like when I first started, for the first project I did, which was Blind.io, the hacking framework, I literally, because I always start 8 o'clock, like 7:59, I'd be filled with the existential dread of like, oh my god, what am I going to say for 2 hours? Like, my heart will be racing, and I'll be like, do I want to click this button? And now I'm like, hurry up, 8 o'clock, let's go. I've got stuff to be doing. Like, come on, I got stuff to say. I've got stuff to write. So it's like anything, right? You just, proficiency comes with practice. Although I wouldn't say, I don't know if I'm any good at this, but I sure do it twice a week. Brad and Sarah, thank you, kind words. I don't think I'd be tempted in game dev by industry. I'd never say never. I don't know. Do I want to work in the game dev industry? I think it depends on the role. I would probably want a more, I don't know, like leadership role or something where I'm running a team. But the problem with that is that I don't have the industry experience to maybe have the credentials to do it. So I think it'd be very hard for me to break in to the kind of role that I would want. So I'd never say never, but I don't know. No, I don't have a target number of commits per stream a week, because like it's just the work is the work. Also, I'm very much a over committer. Like I like to commit frequently and make like kind of small self-contained commits. So it really depends how much of the work kind of falls into that. But also sometimes I'm just exhausted. I'm just like, you know what, just integrated changes done. Like because I'm not perfect, and I try to practice what I preach, but it's sometimes it's just taxing sometimes. Oh, lots of good questions. I think might be a bit more a chatty one today, so I'm happy to kind of go through some more questions. So, how to get more unique ideas? Are you asking how do I get my ideas, or how you can get unique ideas? How long have I been developing the game engine for this game? So this specific iteration, get there in the end. This specific iteration of the game is only a year and a bit old, because I started absolutely from scratch with main to game on the last project, and now I'm building on that. I have been kind of playing around with making engines for on and off for like probably like 5 or so years, maybe more. Maybe more actually. So my design is probably heavily influenced by that, but this kind of like the code you're seeing here is at most a year old. Incarnation, is that what I want? Incantation, whatever. You know what you know what I mean. Like words are hard. AI first approach for game dev. AI is such a weird one, right? Because it's just programming languages are tools, AI are tools, right? AI helps you write some programs faster. You still have to have some sort of kind of understanding of what's going on. So it really depends what you're doing, right? So there's a fundamental difference, okay, between programming and software engineering. Okay, programming is the task, software engineering is the job, right? So software engineering consists of a whole multitude of things that you have to do, like requirements capture and planning and design and testing, deployment, maintenance, security, documentation, compliance and legal, and a small part of that, if you're lucky, is programming. But all those parts can be potentially automated by AI, but they're all multiple facets of the same job. If you're like a hobbyist programmer, then sure, you can just like use AI to automate that if you want. But there's a difference between kind of like vibe coding something and then actually developing something for deployment. And I think those two get a little bit muddied these days. Like if you just want to lash some code together, vibe coding is great, right? Or AI tools are great. And is that any different to 10 years ago if you're just copying and pasting stuff you didn't understand off a Stack Overflow just to get something to work? It's just more efficient. But I think, yeah, but that is not the job, right? That is just one facet of the job. So I did go on a little bit of a tangent there. Apologies. I don't even know if you answered your original question, but like I get asked this question a lot, and I think that's kind of my view on it. Like, if AI helps you deliver value or do the thing you want to do, that's great, but it's not a substitute for kind of learning, I don't think. Yeah, button pressed. Oh, if you want to make a game, do not do what I'm doing, right? Find an engine and just write it. If you just want to create a game, right? If you just want to craft an experience that people can like interact with and enjoy, like if that is your goal, then your goal is not writing a game engine, right? So use Unity or Unreal or Godot or Ray or whatever you want. If you want to, and he said Raylib, that's not the point I'm trying to make. If you want to learn a bit more about the tech, then you can kind of take a step below that and use something like SFML, STL, Raylib, something that gives you a bit like a framework, something that gives you a lot of the moving parts, and then you can just learn how they kind of glue together and how to build it on top of that. If you want to learn how it all works and make no progress in making a game, then you can do what I'm doing and build it all from scratch. Yeah, so I think the latest de novo bypasses are all hypervisors, right? They just basically involves you installing a rando driver that someone on the internet has written, and letting it have control of your system. And then there's certain AMD and Intel instructions that you can use, which allow you to emulate certain other instructions, which means you can then emulate like the CPU ID, which is like the main one. Set get VV or whatever it is. There's a couple of instructions that they use to generate hardware IDs. Everything else is kind of part of the platform, which is easier to spoof, even from a kernel driver. But yeah, I find it kind of interesting that there's a lot of people who are kind of willing to install a random driver to the internet, but also are kind of up in arms against kernel level anti-cheats. I'm not saying either of those are right, but I'm saying people there's definitely not everyone is consistent in their views on those. I'll write some code and then I'll come back to some more questions. So I've always been Intel, but I've recently switched to AMD on my latest PC, and basically always been NVIDIA. Okay, what was I doing? Persistent buffer. Did I make that? Did I do that? Okay. So what else have we got? We've got the multi-buffer. One of these is header only, which I think is this one, so that's fine. So we could auto name const the string view. Can then return buffer.name. Okay, that's fine. Is that the only buffer we've got? There's command buffer. I don't know if I need it from that. I might do. Yeah. To be honest, actually, let's expose it. I think all these other buffers probably need toString as well, potentially. I'm going to try and close as many as I can today. Like, that's kind of the point. Like, but it's a little more chill. I feel like because most streams I try to have like an end goal because I feel it's kind of a nice way to wrap it up. So like, what can I do in 2 hours? Don't always do it, but today it's more just like, what can we rattle through? So auto command buffer name const the string view return command buffer dot name. And I assume I have to provide a name for this. Oh, interesting. This should as well. While I'm here, drive by fix or separate. I'll do that separately, but this needs to have a separate name as well, because now I have 2 command buffers. They both have the same name, which is confusing. What's a good, hang on, forever 0. I'm going to try and get to you, but I feel like this is great shorts fodder. So let me try and articulate my thoughts. So the question is, Java or C++, which should you learn first? It doesn't really matter in the grand scheme of things, right? Unless you're learning it for a specific role. Like, you should pick whichever one like seems fun. If you're learning, like, if you've never learned any programming language before, it probably doesn't matter, but Java will probably be easier. There's a lot of oddities and curios and edge cases to C++ that I think can be quite frustrating for a newcomer. C++ is not a beginner-friendly language. So in that sense, like, faced with no other choice, like, and you picked arbitrarily those 2, like, learn Java, learn what a class is, learn what an if statement is, learn what a for loop is. And then once you've kind of got the basics of that, it suddenly starts becoming a lot easier to pick up other languages, or at least the basics. I would probably suggest Python or JavaScript as an alternative first language if you're looking for one. But yeah, at the end of the day, I just wouldn't want the misery of C++ or the potential misery of C++ to put you off programming when there are other kind of more beginner-friendly languages. If you're interested in learning systems programming, I'd actually probably suggest you start with C, because it's a much simpler language, but it will still get you exposed to like dynamic memory allocation, to pointers, to a whole host of other things as well. So that would be my opinion. Well, that's the classic. That's the classic quote. I think it's from Biana, isn't it? It's like, in C, it's very easy to shoot yourself in the foot. In C++, it's a lot harder, but if you do succeed, you will blow your entire leg off. No, I've absolutely no desire to write an engine assembly. That sounds like a massive... Like, if you want to do it, that's fine. More power to you. That sounds like a massive waste of my time, because I just don't think I'll get anything done. Okay, we'll add the command buffer name later, because I think what I am missing is auto to string const string. Let's go through and add some of these, because again, we have... I might go through that actually in a second, how the toString works for anyone new, because it is kind of interesting. Also, I'm really running low on shorts as well, so I'm desperate to try and squeeze as many out as I can. The old stood sting. mean these questions haven't been interesting? Rude. Cracker says your questions are shit. Let's do name and size. Brutal. Technically, actually, I think it is better. It should elide those calls potentially. Anyway, I think that's better in case they just do anything more interesting. I like children. I like both audiences the same. Okay, so this is another great question. I will pause and answer this because this kind of builds on what I said previously. Is like, so part of my role in my professional career is training and mentoring junior talents like graduates and interns and stuff like that. And I kind of get like, how do you learn in the age of agents? I think AI, again, sorry, a bit of AI focus here, but like I think AI is more useful to senior developers and people who have like the experience to understand when things go wrong and what that means and the kind of the ability to debug. And the reason I say that is because what I think LLMs are good at is allowing you to avoid the easy beginner mistakes. So the code that it will crap out is normally pretty good and kind of will not fall foul of a lot of common beginner mistakes, which means you kind of, if you kind of believe in the fact, which I do, that you learn through mistakes, you've kind of denied yourself the chance to make a lot of beginner mistakes. So the first issue you will face will actually probably be quite advanced, and you've not had any of the kind of like mental fortitude and practice of kind of working through beginner problems and beginner issues. So I think that's the biggest problem for me, is that it kind of smash cuts you to harder problems, especially if the code is a complete mess or spaghetti code, or you don't really understand what it's printed out, and like just saying Claude please fix it will only get you so far. So I really recommend people learning to still write lots of code, just write lots of code and figure out the bugs and the weird oddities in the syntax and why it did this when you're expecting to do that, and build up that kind of mental fortitude to be able to plod through miserable problems. That being said, like use an LLM as like a glorified Google. I think that's absolutely fine. Like, please assemble me all the information around these docs and everything. But just try not, because it's so super tempting to become reliant on it. Be like, can you just fix this little bit of syntax for me? But like, if it's like, oh, what is the syntax for this? Like, if you know, if you can imagine, it's like Google with, well, I was going to say Google without the ads, but I understand ChatGPT is kind of going that way at the moment. So yeah, that would be kind of my view. Is I still think it comes back to the difference between like programming and software engineering. I still think you want to build out your programming skills, and I think part of that is making beginner mistakes and then learning from them. Button pressed. Yeah, so I mean, the only AI I'm planning on using in this project is for stuff that is kind of textbook, and I don't necessarily care about the implementation. So a good example of this, and actually this is actually I think quite a good example because we got it wrong a few times, is I needed some specific values for the vertex data for a cube, right? Like the actual semantics of it is entirely irrelevant. I needed these specific numbers, right? And in fact, I needed more numbers, okay? I needed in addition to UVs, in addition to normals, I needed tangents and bitangents. Obviously, you can calculate 1 from 2 if you've got, you can calculate the third if you've got 2, but let's ignore that. I was like, LLM, given these things, what are the ones? And it's like, statistically, these are the most likely numbers to appear, and they were always wrong. So in the end, I was like, okay, like I know, given like I just like some knowledge I had, like I know I can calculate the bitangents and tangents given the normals and the UVs and the positions, right? So I was like, hey, what's the algorithm for calculating these? And it crapped out this, and like it worked first time, absolutely fine. Like obviously I changed it to be my coding style and used my my built-in types, but that is like textbook information. Like that is just a known algorithm that would exist in the literature somewhere. And there is little for me to be gained by, 1, deriving it from first principle, 2, spending the time just like rote copying it from an article somewhere. and there's not enough interesting C++ in here for me to take the time to kind of go over it. So that is a perfect, that just cuts down a little bit of time and I can get on my day and it unsticks me. So that, I think that is the kind of the most I will use any kind of auto-gen code for this. Everything else I plan on just typing out from scratch. Good chats, good questions today. You rewrote the same class 5 times. Is that good? I mean, it really depends what your end goal is, right? Like, don't let the perfect be the enemy of the good, though. At some point, good is good enough, and you just need to make progress. It's very easy to get stuck in like analysis paralysis of like, oh, this class could just be a little bit better, a little bit simpler, a little bit more idiomatic. And at some point, you've just got to make progress. Like, you've got to keep writing code that makes progress, and you just got to leave it, and then you can always come to, do what we're doing today. You can reflect on it a bit later and go like, okay, maybe I can tweak a few things now to make my life a little bit easier. But I wouldn't stress too much. Like, just make progress, because the next project will be better, and then the one after that, and then the one after that. Yeah, you do got to keep on the timestamps of stuff, because stuff does change. Okay, right. Buffers. I think this persistent buffer also needs a auto to string const string. String that up. Yeah. Do I have any other useful information here? I have the size, which I don't expose for reasons unknown. Guess I don't need them. Again, a large part of this project is only writing the code that I need now, because it's just because I'm a one-man band just trying to get through this in 12 months ish. So if I don't, it's very easy to look at this code and be like, oh well, obviously you need all this, and like, well, it's not obvious, because like if I don't need it now, I'm not going to write it. We could spend months and months crafting the most perfect implementation of a matrix class, but if I don't use 90% of the methods, I've just wasted my time. So like my vector implementation and all my maths classes are woefully lacking in functionality, because I just don't need them. Like, I've not implemented vector subtraction yet, because nowhere in my code have I needed to subtract 2 vectors. So that's, again, kind of one of the tenets I'm on at the moment. It's just like, just try and write the code that we need. Occasionally I'll indulge myself and do a bit of C++ wankery for stuff that we don't need. But by and large, I'm just trying to make the relentless march of progress. Okay. Does this still run? Yeah, exactly. Yagni, you ain't gonna need it. I think feature creep comes with experience, or the ability to spot it. It's very easy to get wrapped up in what you're doing. Okay, so that's what we've done. We've add name and toString to buffer classes. Just got that. Okay. Yeah, bish bash bosh, another commit done. Let me just quickly, I need to do the command buffer, changing name. But let's go, so you might be wondering why I'm adding toString. Okay, why am I adding toString to a lot of my methods? One, it's kind of a useful thing to do, but it'd be like, but I really want to rely on. So the question is, right, why am I adding toString to all my methods rather than overloading for std formatter? Okay, because ideally we want to be able to do std print ln and then the an instantiation of a class, and then it prints out something. Std formatter, the implementation is it's a little bit verbose, right? You have to create a class and you have to implement certain methods, and it's a kind of okay, but it's quite a lot of boilerplate. What I really want is something simple like toString, but then there's no way that std formatter, std print ln, whatever, can understand and consume print toString. except for what I have is a custom. So basically what I end up doing is writing like one formatter to rule them all, right? It's a templated formatter. So these are the two functions that you must implement for format to do format things. Parse allows you to have like custom things between the curly braces. Don't really care about that, but format is like the crux of it, right? So what I ended up doing is I did some little bit of C++ templatey magic, right, with what's called a CPO, a customization point object, okay? And it basically boils down to this special inline context for blah, blah, blah. But what it allows me to do is it allows me to have two call operators, okay, which take a T, like a templated object. And I can basically match to either of these two based on certain properties of T. So if T has a toString method, then it will call this, and then it'll invoke that, and it will return the string, okay? But also, more importantly, if T has a freestanding toString method, okay, so there's just a free function somewhere called toString which takes of type T, then it will call that on this. And something template magic basically allows me to take any object and instantiate a formatter for it, and as long as that object has either a toString member method or a freestanding toString function, then it will automatically call that, and then it will work with std format. So the idea being is now I can freely use std print ln, std print, std format, whatever, as long as I just implement a much simpler interface, which is toString. Now the question is like, why have a freestanding toString? Why not just force everything to have a member? And I'm going to try and find a good example of this. I bet I don't have one. Sorry, I'll cut this bit out in the short. There's a good one. That's the test. Sorry, ruined the magic a little bit by not having this prepared. Here we go. This is what I want. Here you go. So the reason you might have a freestanding function is for enums, right? So you can't have a member function on an enum, but for instance, like this key, which has definitely not all the keys on the keyboard, but at least some of them, or at least the ones I care about, I can define a toString function and then convert that to a string. So this means now that for any enum or for any object, I can pretty much with minimal code get it to work with std format. So anyway, that's kind of a little bit of fun C++-iness for you. Anyway, okay, fine. So let's go to command buffer, and let's take this. So this should take a std string view name, okay? And then this should take a std string view name. And then I think what I'll do is I will have a std format that and then name. So I've not really done this anywhere. Do I want to do that? Do I want to impose a namespace, or should people just put their own namespace in? I've not done it anywhere else. So this is actually a design question now. So I have a command buffer. Say it's like the main command buffer, right? I could call it main command buffer. I could call it main. I could call it whatever I want. Do I want to internally? No, because I think it'd be confusing because you would not get the name that you put in. So actually, I think this can just stay as name. Sorry, I'll answer my own question there. I think it would be confusing to a user of this class to give it a name and then call .name on it later and it have changed. I believe quite firmly in the principle of least surprise and the fact that the code you are executing should do the least surprising thing given your understanding of the system, and I think that somewhat goes some way towards violating it. Do we need to store the name in that class too? Oh, good question. I think no, because I think we'll just pass it on to the buffer, because when we call name, we just return it from the buffer. It'd be duplicate information. I don't think there's any need to. That log can go away as well. Don't need that. Oh, well, this needs then. Oh, actually, I think we can simplify this function now, right? So resize, sorry, more templates. This function here just resizes a GPU buffer. Okay, so given the CPU buffer that is backing it, and some buffer-like object for the GPU, could be the persistent one, could be the regular one, could be whatever, it checks to see if the CPU buffer can fit into the GPU buffer. If not, it doubles the size of the GPU buffer, and then it copies the data across, and it does some barrier there. Oh, it doesn't copy the data across, it just grows it. Sorry. But I always pass in the name, but I think now... I think we can basically say... hang on, understood is convertible. This is convertible. String view. I can't remember if that's correct. Oh well, we'll just say it has to have a T name. So I'm basically just saying that anything that looks like a buffer, if you can write to it and it can return a name, it needs to be inside of that. Is it this? Std is convertible std string view. Two. I need type traits. I can't remember. This is not a rune I use that often. Is it not convertible too? It was in the format, was it? Okay. Std convertible too, that's why. Is that, what's that in? Is that concepts? I bet it is. I think if I remember, the is underscore are type traits and the non-is ones are... It's outside. Wow. We should re-pick a lane. Maybe it's type traits. Convertible. There you go. Got there in the end. Okay. Sorry, we got there in the end. Thank you. So this is just extending so the concept is just a way of kind of defining the concept of something, right? It's a way of kind of applying restrictions on a type. It basically simplifies and removes all the spin misery that we had to do before. So this basically just extends what does it mean for a buffer, for something to be considered a buffer within our type system, right? And you have to be able to write data to it with an offset, and now we have to be able to invoke a name on it. So what that means is I can now get rid of the name here, and we're guaranteed that GPU buffer has a name, right? By the way, there's one could argue you don't need this, right? Because at the point of template instantiation, if you didn't have a .name or a .write, whatever it is, then you would get compilation error, right? However, failing a concept tends to give a better error, tends to give a better compiler error, especially instead if you're having to do it through SVN or were having to do it through SVN. I am aware of Tokyo Spliff. Occasionally he pops into these streams, which is quite cool. So hang around long enough, and he might say hi. He might be here. He could be here right now. I would rate my knowledge, C++ knowledge from. Can I do 0 to 10? Because I feel that's I feel like a finer grain. I would say my C++ knowledge is probably around a 6 out of 10. Okay, so this should now cause a bunch of errors because oh no, it won't fail the template. The function signature has changed, hasn't it? So we need to find the resize GPU buffer. Obviously, the first one I pick is the one that I've already changed. Resize GPU buffer. This is nice. I like this. I like stuff like this. This is simplifying the code nicely. Look at all these rando strings I was having to pass around. How do I keep my eyes healthy? I don't know. Like, obviously, take 15-minute breaks every 45 minutes to stare at something in the distance, like the government recommends, or just have regular eye checkups and hope for the best. What do I think about Rust for game development? Like, I really, like, in the nice possible way, like, I don't actually care that much about programming language choice. Like, if you want to make a game, you should pick whatever gets you there, right? We were having this discussion earlier. If you know Rust or you want to learn some Rust, then writing a game is it'll either help you write a game or it'll help you learn Rust, right? I think it's absolutely fine. I don't think all the big studios are going to throw all their C++ code away in favor of Rust, but I think you can definitely write a game in it. I suspect. So I mean, like, I have a lot of respect for Jonathan Blow in the sense that he's obviously shipped some very complex and very interesting games, and he is clearly a veteran of the industry. I suspect we would disagree quite a lot on our view of software engineering and programming language design, but I think that's fine. I think it would be an interesting discourse. Material manager. Yeah, I think so. I think if the debate is how you get to the right answer, right? Or even if you don't get to the right answer, it's how you broaden your horizon. I'd be like, why is our AI so bad? Renderer. Where's the? There's the badger. Yeah, exactly. Like, as long as everyone's like amenable towards the debate, right? Do you know what I mean? It's not the point of the debate is not necessarily to change the point of view of someone else's mind. It's to make sure that kind of everyone has all the inputs needed to make a decision. What have I? And so my concept is failing now. So I've called it with something. Fake buffer. I'm failing in the tests. That's fun. What tests have I got for multi-buffer tests? Here we go. What is that? What's the string? Oh, actually, I even take the name. What am I doing? Oh, I've now got a clash. Interesting. Okay, fine. Let's make this class. Let's make these public. Make these underscores. That should probably align with the others and be a string. A strong. Okay. Does that blend? Okay. So I'm hoping this. Okay, I'm pretty much at the point I wanted to be now, which is where the Christ, whatever the hell that is. Oh, what? Whoa. Okay, this error keeps on going. I got errors for days. Still got this somewhere. Mesh manager. Mesh manager. Resize GPU. Oops, steady. Stay on target. All right. What is this error? Why is it? Where's this a quality issue coming from? I saw Google test. I've definitely got an error in some of my test code somewhere. Yeah, it doesn't like my fate. Why did I remember? 16. I bet I've used the literal. Have I used the literal? It feels like I've used the literal. Yes, here we go. Because that is now, these are now functions. All right, there we go. And then I need to have the size. Okay, fine. Auto size const the size t return size. I don't really understand, Elijah. I don't really understand what you're saying. I'm afraid. I apologize. There's no way to learn C++ fast. There's no way to learn anything fast. Learning just takes time and practice, right? Yeah, thanks. Got there in the end. The fake buffer is just for testing, right? Because there's a lot of our multi-buffer, right? It's just a templated class which wraps a buffer and does like triple buffering, which allows us to update stuff frequently. And then because we got, assuming the buffer is mapped and coherent, and you can just write to a pointer, and that magically ends up on the GPU. You have to be careful that the GPU is not reading from it as you're writing from it. So which means we need to do something like triple buffering, where we actually triple the amount of space and then chunk that into thirds and then write to one and then advance, so that as the GPU is reading the previous one, we are then writing to the next one, and 3 should give you enough that you would never accidentally trample your own data. That's quite a lot of logic. So what I ended up doing was writing a templated class which handles a lot of that. It's actually not a lot of logic, but it's quite important logic. But the idea being that the underlying buffer is kind of irrelevant, right? So as long as it exposes something that is indeed a buffer. So what I did is I wrote some unit tests for it and then just used a fake buffer to drive it. I think like hand-coded written programming exams are just a terrible idea. Fake buffer. Oh, someone said I'm missing something somewhere. 17. That shouldn't make any difference because it's part of the grammar is you can just have an empty expression statement on like in a lot of places. So that would just introduce an empty expression statement. Yeah. So that's fine. Yeah, it's just OpenGL at the moment, really. It's the only library we're using. I suppose I could just go and look at the error message. No matching function call for fake buffer, Where am I actually? Doesn't like my construction of this, 48. Why is it not like this? Oh, well, my setup's not perfect, right? There's always ways to improve it. Why is it not like that now? What am I missing? This takes... I mean, that should technically be const ref, right? Or I should move it in. It's only a test, but I should still try and keep test code clean. I'm struggling to understand why it doesn't like this. Multi-buffer just requires that it is buffer. No matching function call to embrace this list. There are 3 candidates. Const string. No known conversion from string view to string. You sure? That's something I didn't want to faff around with. Where's that actually coming from, though? 48. So let's get multi-buffer up. SV? That seems wrong. I could go and fix these command buffer ones, so this is a little bit cleaner. Definitely doesn't like... What am I missing? I'm missing something trivial here. So why is it not like passing it to buffer, which is indeed type fake buffer? So the issue is that I pass what is now a string view, okay, which matches multi-buffer here. This then goes into a buffer, which is of type buffer, which is of type fake buffer. Bear with me. And then it's not liking passing that. I mean, I guess maybe that... I don't understand why that would work, because you can construct one from the other. Well, sometimes you've got to accept your lot in life that things are confusing. I'd have to look into that. Hence why I consider myself only a 6 out of 10 in C++. So command buffer, this is the main command buffer. No, that is the G buffer command buffer, right? And then this would be the post processing command buffer, which at the moment is for the light pass, but we can the beauty of using the command buffer is that we can reuse that for every post-processing effect because it contains just one command for rendering a full screen sprite. Gbuffer, yeah, oh, not that. Has using modern C++ exclusively bitten me in the back? Not really, but I don't really understand the implication. Like, could you give me a scenario? Like, I don't think so. Like, it allows me to make progress and write. It allows me to write a lot less code than you would think. Okay, that's still working. Just for everyone's compression rate. Okay. That's actually an annoying amount of code to add. Oh, because I changed. Oh, I've done two things, haven't I? That's a little bit annoying. Let's do command buffer had a name, and command buffer had a name, and then I don't think I had to change anything else for that. So that is oh, actually, it's the call sites as well, isn't it? It'd be renderer, right? So that, and then commit. So construct command buffer with name, and the rest of this is basically refactor, resize GPU buffer to not need name. Cool. Not it. I mean, C++ always has quirks, regardless of which version you're using. It's always full of quirks. One might argue that modern versions should have less because they're trying to introduce less UB into the standard and stuff. So, and like one of the things with C++, right, is that the standards committee don't really want to break backwards compatibility, so it's kind of hard to remove things from the language. What you can do is add more stuff to make the shit stuff less shit, right? So using newer versions often gives you access to like better syntactic sugar and better primitives and stuff like that, which ultimately means you are hopefully avoiding more and more of those foot guns. No, I'm not interested in AAA development. Like, fair play to people who do it. It sounds difficult. Okay, so we've done that. I think the next one I want to do is, I don't think some of our buffers are particularly... I don't think the usage of some of our buffers is particularly great. So let's have a look at some of the managers, because these are the things that own the underlying buffer. So we've got a mesh manager, a texture manager, and a material manager. These own respectively the meshes, the materials, and the textures. So we have kind of two buffers types that we can use, like effectively under the hood. We have a write once, like a sort of slow update one, which you just use GL sub buffer data to update data to, and it will probably cause a sync. And then we've got the persistent coherent mapped whatever it is one, which is faster to write to. But the danger with that being faster to write to is we need to triple buffer it. So effectively we're in a situation where we can have smaller data that is slower to write to, or faster or bigger data that is faster to write to, effectively. And like, for the amount of data this game is going to have, we could just use the fast one for everything. However, I do want to try and engineer this a little bit sensibly. So for stuff that doesn't update each frame, we shouldn't be using the triple buffered data, right? And having to like do frame management and all stuff like that. It should be like if updating the data, if updating the GPU resident data happens infrequently, then we should just take a slower code path to do it. So that's stuff like textures and materials. Those should not be updating every frame. We are not streaming data in and out, right? The idea being that when the level loads, it should preload everything. So to have to add a new textural material mid-frame is going to be quite rare. So I think we can simplify the code and take a slower approach. Stuff like meshes potentially, but also like command buffers, entities, lights, like anything like that, which could be changing each frame. And changing also includes like moving it around, right? Like the data is volatile, then that needs to take like the more efficient route. So I just want to kind of review what we're doing and make sure we're using the right buffers for everything. And I think Material Manager is overly complex, and we can shrink that down a little bit. Lucas, team member, thank you very much on YouTube, much appreciated. No, I'm not. I'm just using OpenGL 4.6 MDI. I'm not using the NVIDIA extension. Okay, so let's look at, I think Texture Manager was the last one we wrote, and I think is probably like the closest to what we actually want. So yeah, you have a CPU buffer, a GPU buffer, and you can add textures to that, which is considered like a slow operation. And I think Texture Manager adding gets the index, sticks the data back, sticks into the CPU, resizes the GPU, and then just writes the data, right? Which internally this will call GL sync, I think, GL finish, whatever the barrier function is, right? So I think this is fine, right? And then add a range just does it with ranges, and that's fine. Flush, thank you, GL flush. GL finish. We were all wrong. So that's fine because textures are, again, like I said, textures are always resident. Once you load a texture, you have it till the texture manager goes away, which is probably when the scene goes away, which is probably when the game ends. And they're basically append only, right? So once you've loaded a texture in, it's stuck there, and then it means because we're using bindless textures, we can just pass around indices in our various shaders via whatever SSBOs or uniforms, whatever, it doesn't really matter. But the fundamental point being that we can just have a massive global array of textures on the GPU, and then we can just use indices to kind of pull those in. So that's fine. So that's kind of what we want. What are the managers we got? Mesh Manager. So I think Mesh Manager is the same. It just has 2 CPU vertices and 2 GPU vertices. So the design of this is that all mesh data, right, every model that is to be rendered, or every mesh that is to be rendered, lives in one massive GPU buffer, okay? Again, loading models should be a slow operation. You should just preload everything, okay, and then just use them as you need to. We are not going to have levels so big, I don't think, that you are going to need to kind of juggle loads of different models. If we do, then we can solve that problem later. But I think for the size of level I'm kind of considering, and for the complexity of the game, we're going to keep it simple. We're just going to squirt everything into one massive GPU buffer, right? And then again, we can then just render with offsets into this, right? So your gun model could be next to the floor panel, could be next to like an enemy, right? And then we just render different strides within that. So that's fine. I think the Material Manager I went a little bit mad with. Yeah. So the Material Manager, I have it so that you can add and remove materials, which has then a lot of bookkeeping involved, because effectively I have to be able to follow, because I want to be able to pass an index, right, into the, if we look at the fragment shader, right, I pass in an index, right? So each entity that gets rendered stores an index, and that index gets passed to the GPU, and the GPU then uses that index to look up into the global array of all materials. But the problem is, if you can add and remove stuff, right, then those indices can change, and that's a problem, right? So what I did is I have this concept of a material key, and that material key can be resolved in the render loop to the current index. It just means that the material key will never change, right? So if the actual material in the vector underneath changes index, the key remains remains the same, and you can just use that to resolve the index at that point. Is that right? Like, do we want to add and remove materials? Is that functionality we need, or did I just go mad with it? Also, I don't think it needs to be multi-buffer persistent. I think, like, if you're just updating a new material, we shouldn't be creating loads of materials on the fly, right? Again, we should be just kind of setting everything up at the beginning and then going with it. So I'm kind of tempted to really strip this right back to like the texture manager, and you just have a CPU buffer and a GPU buffer, and you just add stuff and sync them. Yeah, I think it should be the same as textures, right? I cannot conceive of a world where we're having to not create texture, like where we're going not streaming textures in and out, but having to stream materials in and out. So I think this is a good refactor. Let's kind of go through this because this will simplify the code a lot. I did want to have a play around with flat map, but you know, what are you gonna do? So let's get rid of, like, this is, remember, when refactoring, all the best diffs are red. So this would be quite nice, this. So yeah, but if the level editor, like, you're not on the hot path, like, your level editor probably is not running as fast as your main game, right? Because you'll be having other, you probably won't be, you might be paused, not simulating physics, you might not be having particle effects. You could, I think the level editor doesn't have to run as fast as the full game. And again, you'll probably only have to be modifying materials based on like mouse clicks, right? Oh, I don't want this material, I want this new material. And at that point, you're already on the slow path anyway, because you're having to go via mouse clicks and stuff and, click, wait, done. So I think we can strip this quite back a bit. There was some fun code in here, but I think we can probably keep the templated add, to be honest. Like, I think there's no reason we couldn't still have this. So how does the texture manager work? This returns when you add, this returns the index, right? So this should be now stood unit HTT, and then blah, 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 let's sack all this off. It's going to largely be the same as this, right? So we're going to do... actually, let's start changing this. So let's do the material data CPU side is just going to be a vector of material data, okay? Just doing some refactoring from the last few streams, just paying back a little bit of tech debt. This is the last one I want to do, and then for this, I really want to spend like the last 40 minutes or so doing some ImGui stuff. I'd really like to be able to render out all the passes, but it's quite a big refactor. But I want to just do this super quick. So I think this, right, correct me if I'm wrong, I think that just becomes buffer. All right, and okay, and then so we can do const auto new index equals material data GPU dot size, right? Because that will always be the next index. And then we can do auto new material equals, so now we can do material data CPU, right? Dot emplace back stood forward arg. So this will give us the perfect forwarding, right? So this will be whatever arguments we pass to the add function will just get forwarded on to the constructor of material data. Okay, so that's nice. It means we don't have to kind of construct this struct outside and then like move it in or pass it in or whatever, or construct it in. We can just be like, this index, you just pass it three integers, right? Bang, 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 and it will just construct it. I then need to do, so that sticks that in there, and then need to resize the GPU buffer because this might have changed. So this will be the, I might change the names as well. There's no need, like, material data CPU and material data GPU could just be CPU buffer and GPU buffer. There's no need for those to have additional naming there. Like, it's obvious if those are the only two members, that's the material data. New material does need to be a ref. Correct. Thank you. I think material is copyable actually. So yeah, that would have been an extra copy. Okay, and then we're going to do GPU buffer dot. Now that we know we definitely have enough space, stood as bytes. The span. Do I even need? I don't think I even need new material, and I think I don't need it in the other one either, actually, because I just write all the data. It's slow, right? I'm just going to write all the data. Material data CPU dot data. Material data CPU dot size. From the beginning, and then return new index. All right, it's obviously not. Okay. Right, what are you not liking about this? Where have I goofed? There we go. Okay, fine, cool, nice and simple. Quite tight code, I think. And then we can sack off this because we no longer need this. This was using C++23. Oh no, it wasn't even using deducing this. Failed code review. Don't need the index. Oh, look how like much less code this is. Don't need to synchronize it. Do need NATO. Don't need to advance it. Bish bash bosh. So this just becomes data. Why is that not a span? I feel like this should be a span. All right. Oh no, wait a minute. No, it shouldn't just be. It should be a const span. There you go. Oh, writing tests for GPU stuff is so difficult to do. I don't really have an answer for it. Like, you just test the things you can test. Like, I test all my maths primitives. There's a few buffer primitives that are templated, so I can create fakes for it. You could construct like a whole fake OpenGL state machine and test that, but that sounds like a lot of work. I would defer to someone in the industry because I don't really know I don't really have the answer. Yes, there's been an FPS game one day. Okay, I think that's good. Obviously, all the call sites were now changed. Okay, so let's do. I think a lot of this is going to be in main, right? So push back. Oh, hang on. Go. Material key. So this is now just stood uint32t material index. C stood int So this is quite nice, right? Our entity at the moment is super lightweight. It has a name, it has a non-owning view of some mesh data that needs to be rendered. It has a transform, okay, so how it appears in 3D space, and then just has an index to the material, and that is it, right? And then we just create command buffers from those and render them. Okay, so now we can replace this with so this is material. Again, I would say this is one of the nice things about auto, right? Is that I've changed the return value of this, okay, and this will still continue to deduce the right type. Oh, so it's changed the variable name, so it does, my point isn't great there, but like. Okay, so that's all that done. So now I think, I suspect the next one will be in the renderer. I think we just have to have something there. Because we actually don't have a material for the post-processing sprite, but that's fine. It's not great, but it's fine. So here we go. So now I don't need to get the index from that. What I can do is the material index becomes e dot material index. I don't even need to capture that, so that becomes a stateless lambda. Absolutely crushing it today. Don't need to synchronize it. Don't need to advance it. Bish bash bosh. See if it runs. Oh, look at that. Beautiful. Perfect. Perfect refactor. What could go wrong? So this is now simplify material manager. Very like that. That is, look at that diff. Mostly all the best diffs are red. Look at that. Just deleted loads of unnecessary code there. Pleased with that. Did I just reset my changes? No. Okay, right. So now bish bash bosh, half an hour. Let's go. I really want to enable the docking feature in ImGui. I think that will help us. So yeah, I know. Just throw it away, mate. Just straight into the sea. So docking has a bit of a strange history with ImGui in that it exists entirely on a separate branch because the developer basically he's not happy with the current state of it and he wants to rewrite it, but it's been in there for ages and it's stable, and I think all the other changes are also like cherry picked or ported across to it, so it's a little bit of a shame, but it is what it is. So I think we can just grab whatever the latest version of the docking branch is. So let's do CMake and then ImGui. So I think it said I can just do docking, right? Let's just rerun that. That should bring down any changes. And then let's just do make run. So let's just check we can build and run against the docking branch. There's not been any weird API changes. I believe the plugins all still work. Okay, fine. So at the moment, nothing. No difference so far. So now, I think what I need to do then is go to. Don't change any of that. Debug UI. I want to change debug UI to subclass renderer, so I have access to all the internal frame buffers. That's what I want to do. What the hell is that? I guess I don't need that. Classic. Yeah, mate, it's pre-recorded. I'm making up all the conversations as I go along. So I think somewhere where I set this up, I think I need to do io dot config flags XOR equals ImGui config flags docking enabled, right? And then I need to create so this, at the moment I rendered to like the default window, and that I think that needs to change. I think that needs to become like scene. Okay. And then before all this, I think there's another, I think I need to do I'm just reading off the docs. Doc space overview port. I think that's it. I think that's pretty much all you need. I mean, obviously I need to actually type out the correct runes. No, there'll be no ECS. I won't have enough entities to make it worth it. It'll just be pretty simple, pretty basic architecture, a little bit of like light inheritance. Okay, right, so that's crash. Yeah. Missing end. Ah, yes, of course. It just because each of the windows become dockable from what because I did have a quick squiz through the docs before this. Each of the windows become then dockable, and then every time we create a new window, we can dock it. Okay, that's not quite what I had in mind because the background's gone, but I think I can stick that there and then stick that there. Okay. Which is nice. Obviously, I don't know why. How do I think what's happened is it. Whoa, quicker on YouTube. What's going on? There's somewhere in here which stops you doing what that's doing, because at the moment it's basically creating a blank pane that you can dock to, because you can dock things with inside things. So it creates like a parent one, and I think that renders over everything. But you can make it like transparent, I think. Here we go. To create docs with info where central window is transparent. Okay, fine. I need these runes here. These runes here. Give me these runes. Give me these mystical lines. Obviously, I need to globally namespace it for my insanity. All right, there we go. Can I now undock these? I can. So can I kind of want this to be here and this to be here. There we go. Nice. Look at that. Oh, on YouTube, he's leaked another letter of his name. That's quite nice. So we can do that, and then we can move that around, and then change the color. So I want to basically slowly improve this. So what I want down here is now, in addition to the log, I want the render targets, and then be able to see basically what we're doing. The problem is so I wrote an engine, or I attempted to write an engine before this, which was cross-platform in that it was it was Windows, Linux, Mac OS, iOS, OpenGL, D3D12, and Metal. And the issue I found is that the graphics API, so the cross-platform code in terms of just like system stuff is not too bad. It's quite easy to write an abstraction around it and just have implementation-specific details. The trying to create an abstraction that maps nicely onto both OpenGL and then anything else that's not D3D11 is an absolute pain, and that's, I think, your biggest issue. Banned. Queco name is banned. I quite like this. This is nice. This feels like a commit. So add ImGui docking. Okay, so now let's try adding a new window. This is where we're going to have to. So there's a couple of ways of doing this. So let me explain to you my problem. One of my problems. Let me explain to you the problem I'm having right now. I have these render targets. Okay, cool, like it. Onto it, and they have some number of color attachments. Okay. I think the default locations get saved in the special ImGui ini file that gets auto-created for you. So the render target, right? So there'll be a gbuffer render target, okay, as evidenced by the gbuffer RT member variable. Will have some number of color attachments, okay? What I really want to do is render all those in little squares in real time. So as I can go around, I can see the world space normals, I can see the specular, and I can see the world space positions. I think that will just help with debugging an awful lot. Ideally, I want to be able to click on them and that go over the full screen, but we'll do what we can do, right? This information is very nicely encapsulated inside renderer. So I either need to get render to expose its internals and pass renderer into the debug, because I've got this debug UI class, right? So either renderer is passed into debug UI. I could friend it, is cheating, but I could do that. Or I make renderer a abstract class, and then I have a debug renderer, which then make these private. I'm not really sure which is correct, because I think the subclassing is correct. And I'll tell you for why. I think I need to modify, if I want to be able to click on a texture and have it full screen, right? As in, like, I want to be like, I now want to click on the normals and just have the world, just render the normals, right? Or maybe just the bloom pass, or just the FXAA pass, or something like that. I'm going to need to have to modify what happens at the end of render. And the only way really to do that is to kind of break it up a bit and have some extra functionality in there. Because at the moment, at the end of renderer, right, I feel like I've convinced myself, it blitz something to the frame buffer, to the back buffer, right? So I need to have some customization over this. So whereas if I have like a post render step virtual function, then the debug renderer can override that. Because I don't need them to be pointers, right? What would they be pointing to? It owns the data. Yeah. Okay. Fine. Let's do it. Right. I'm gonna bash this out. Maybe, I don't know. I've not thought enough about that architecture. I think this kind of gets us what I want to now, right? So I think I'm always going to want to do the render, but then I think what I'm going to want is a virtual post render on scene. Ooh, do I need the scene? I think I do need the scene. And this will be protected, okay? So I will have an implementation of that in renderer, right? But let's try and do this bit by bit, okay? Hang on, I'm also going to need a. Yeah, let's see how much we can do. You have to get. I'm going up at 5 a.m. tomorrow, so I really can't be streaming too late. Okay, let's do auto renderer. Why is that not appearing there? Okay, and basically all this is going to do is do this. Okay, and then this is going to call post render theme. Okay, so this is now my. This doesn't actually need it, does it? So this is now my customization point, right? This is a virtual function, so it'll call, but it's not pure virtual, right? So I provide a default implementation. So by default, if I don't override anything, it will just do what we have done before, and we'll check that in a second. However, if I subclass renderer, it will give me the opportunity to provide a different post render functionality. I don't know if I'm going to get that far, but at least kind of like the mechanics is there, because I do want to do that. That might be something we do quickly at the beginning of another stream. Okay, that works. Yes, and get you correct. So if it wants to just do it normally, it could just call the base one. So that's kind of it, right? So now this is going to be getting a little bit nasty, because a bunch of this. You know what? Screw it. Let's make them all protected. If you subclass renderer, you can have access to that lot. Oh, Stargate. Oh man, hope it's SG1. I would maybe accept Atlantis. Okay, so let's do. I think we're going to need a separate subdirectory at some point, but let's. Where does debug live in graphics? Just straight up in there. Okay, e source graphics debug renderer dot h. Okay. Okay, let's do program once. Okay, and then let's bring in graphics renderer. And let's do namespace. Oops. Okay, and then we're gonna do what we're gonna do. We're gonna do class debug renderer. Okay, and then we're gonna do public. We're probably gonna have private as well. And then we're going to go debug renderer, and then that's going to need to take the window. Basically, let's have a look at. I don't know why I'm rewriting all this code when it literally exists. We just need this to be do %s debug UI becomes debug renderer. Probably could have just moved the existing file. In fact, fuck off. Sorry, change my mind. Git move source git move source graphics debug UI .h to source graphics debug renderer. Move that with that. You will do as I tell you to do. Git move source graphics debug UI CPP to source. Oh, why does it keep? Where does this keep coming from? Source graphics debug renderer.cpp. Okay, fine. Get that in the end. I don't think I even watch Universe. I think I gave up. Does my head get cut? How rude, but the answer is also yes. So debug renderer now looks like this. Okay, fine. So we've got all this in here. So now I should be able to just include graphics renderer. Rerun my old command. Make that. Bish bash bosh. Then I should be able to do. I'm just going to leave the default implementations. Oh no, I'm going to need the post one because that's where I'm going to do all the ImGui stuff. Yes. Auto post render scene. Actually, no, this just becomes so much easier. Yes, yes, yes. This just becomes post render. Override. Nice. And then this is going to do public renderer. Non-virtual member function marked override hides. Oh, of course, this now needs to be protected. Can't be const because this needs to make modifications to it. Oh, so annoying. You know what? Concessions must be made. I could cast it away, but that feels somehow worse. Okay, right. So now we're here. So if we go to debug renderer, ClangD's crashed on me. It cares not for my refactor. So let's change this to post render, and then we're going to need to call renderer post render theme. So I'm just going to start near them again. Debug. I bet it was this it didn't like. It makes modifications to the scene because the debug renderer can, when you move stuff with ImGui, right, has to write that back to the scene to persist it. So it's not ideal, but I think it's kind of okay. Okay, this is gonna be a load of errors now. In fact, actually, I'll tell you where one is for free, which won't. Oh, where's the? Maybe it's. That's right. I'm literally on it. Full. Sorry, couldn't see the wood to the trees there. So main's going to be unhappy. Get rid of that. I think we'll just. Ideally, this should probably be some sort of. Oh Christ! It's going to have to pass all this through to the constructor, isn't it? I forgot it needs all access to all this. This is not going to be a quick refactor. Okay, fine. Let's keep going. Let's keep going. I have faith. Right. So this is going to need. Let's do this. width and height we can get from the window, right? So, and we're going to need the window anyway. So let's do const window, okay? And then we'll have const window, all right. So then this means we can just do 38G, bring these over to here, do that, get rid of that. Resource loader, texture manager, and mesh manager. Okay, so that should satisfy that, and that. Okay, ideally it should be like a unique pointer, so I can use the polymorphism and change out the type, but for now it's unlikely I'm ever going to need both a renderer and a debug renderer. Get rid of that, I guess. Okay, fine. So this should be hunky-dory. So then we're going to go to debug renderer CPP. This becomes and then that, like that, to get rid of that, and then our whole thing becomes renderer window resource loader texture manager mesh manager. Structure for what have I missed? I think that's a symptom of not fully implementing window. Sorry, I'm not ignoring chat. I am ignoring chat. Const window, and this becomes window. That should sort that out. Debug renderer, yeah, in fact that has to go because I won't initialize it. So somewhere in here it's not going to like width. So this just becomes window dot which one? Render width. Window dot render width. Sorry, I know it's a little bit gross. Let's bring it over here so I can actually see what I'm bloody doing. Window dot render width. Window dot render height. Window dot that, and then window dot render height. Right. Okay, fine. We're getting there. Of course, this now just needs to pass in Windows. That's fine. And then somewhere down here. So this now needs to be render mouse event. And then, ooh, that's a good point. How do I now toggle whether I'm doing this or not? I guess debug renderer needs to now have a bool enabled auto set enabled bool enabled void debug renderer debug renderer enabled equals enabled I'm not a massive fan of early returns, but I think this is actually a good, so if not enabled, return. And then somewhere up here, I need to have enabled false. I've not considered any abstractions because I kind of want to just do it. So that should now be that. So where do we toggle that? So debug mode. So I should be able to just do renderer dot set enabled debug mode. Make that a little bit smaller. How'd that get so? Okay, we're getting there. Oh, close. I can feel it. Render 255. No declaration. Post render. Ah, sorry. Sorry. I see it. I've seen it. The mouse events will not work on a default renderer. Yes, that's fine. Problem for future when we come to ship it. Okay, right. So in theory, I should be able to. Okay, so everything still works. Okay. So let's just commit refactor debug UI to subclass renderer. Okay. I'm actually shocked that worked. So now what I want to do is go to the debug renderer, and I need something like so this should be render targets. Okay, so this should in theory get us a new window. Sorry if you're just joining the chat. I'm really sorry if I'm ignoring you. I'm just desperately trying to get this working. Right. Okay. Fine. Cool. So that's most of the way there. So now I think I can just do something like const auto normal text equals scene dot texture manager dot texture g buffer rt color attachment first color attachment is +1. I'm just doing the normal texture because I think it's easier to visualize. So that should resolve us to the normal texture. Then I think I can just do ImGui image. Is there no image? What's the ImGui image? Image, here we go. Right, and then I want to do I think I can just do normal text dot native handle, and then something like, I don't know, 200 sorry, imvec2 200.9. It's not got the right aspect ratio. But that is pretty sweet. So what's my aspect ratio? Super chat. Thank you so much. How kind. Best of luck. I'm feeling it. I think we're there. I think we're doing it. Yeah, should be able to take the. So let's do. How do I want my auto aspect ratio equals what? Window dot render width over window dot. I'm actually shocked that I'm absolutely generally shocked that worked, right? I think what we probably want to do is you can inspect the window width, and then I probably want to chunk it up into like portions, but looks worse. So it needs to be on width. Have I just made an absolute... Am I just a complete muppet? Still doesn't... It's still the same rendering the same site, so I feel like this is... Oh, hang on. Yes, yes. Oh no, absolute bug. There we go. Now we're cooking. So can I now do const? I don't have template 4 yet. For auto I equals 0u. I is less than g buffer rt dot color attachment count plus I. Hoist this up. And do, let's call that text and text, and this is plus I. Oh, it's probably flipped something OpenGL. Great. How do I get those? I need to get those to appear next to each other. That's pretty cool though. Like that's definitely the requisite parts. How do I get those to appear next to each other? ImGui. Oh, I bet there's some sort of like frame or something I need. ImGui render texture next to each other. Is it same line? So do I do that with something like ImGui same line? Like that? Do I need to put that on each thing, or do I put that at the beginning of the frame? Nailed it. Oh well, sort this out later. To be honest, that's pretty much what I wanted to do. So I'm pretty pleased with that. That's really nice. You're right, it does seem to be upside down. I need to think about that. Why is that? But the angle is still the same. So where do I put same line? Like before each render. Oh god, launched keepsake again. Yeah, I mean, there's lots. Look at that, perfect. There's lots to be done, but I think generally that's pretty. Oh, you're right. It is upside down, isn't it? Yeah. So, ImGui image Y flip between the elements. So it should be technically here then. Oh, well, I've done it there. Can you? Oh, I see. Okay, fine. How do I flip the? Display the text. I want load top down on something. Where am I putting that though? Like where's? Oh, I see. You mean put it at the end there. So ImVec2 is it enough just to do that? Nope. I feel like there's got to be. It seems to think there's like a load top down function. Okay, 0, 1, and then 1, 0. Oh yeah, I am using ImGui. Sorry, that's I guess one of the other libraries I'm using, just because it's just makes life just that little bit easier. Ah, there we go. Now we're cooking with gas. Look at that. Still got a log. Logging hard. Drop this down. This should scale, I think, with this, but for now, like that's pretty good. So yeah, what I want to do is click on these, and then if I like, oh, I just want to inspect the normals, click this, then it renders the whole thing as normal. I probably should have the final one as well. Like have them all. But yeah, I think that's fine. So yeah, if we move these now, they should. I might need to change it so I can still, because at the moment it locks the mouse and I can't freely move. I might have to have some button which allows me to remain mouse control through this. I think that's pretty good. And that's certainly a community. Let me give it a funky color. That's definitely a community post. I don't know why I'm doing this now. I'm going to have to redo it in a minute to retake the post, but that's pretty cool. I can't use render doc though because I'm using bindless textures, which hence why I've had to go through the misery of doing this. No, it's not PBR and it will not be PBR. Okay, fine. Render out render targets. Okay, this is good for a merge, I think. Stream 15. I think that's most of the housekeeping I wanted to do. There's a few other bits and pieces, but I think we'll save those for another day because I really want to get onto model loading next. I think we've got enough stuff now to start thinking about model loading. So let me just stick that in the Git hole. That's what we've done. We've done removed unneeded command buffer. Done. Have GPU store buffer name. Done. Refactor object data to you. Done. Use ImGui docking. Done. Preview frame buffer in ImGui. Done. So next kind of tech debt session, I'll look at this DBI error, warning. Create a pull request. Create a pull request. Right, I'm gonna get that going. Right, good stream. Lots of work done. Good shorts. Yep, I'm gonna head off. In fact, I'm gonna pretty much go to bed because I've got to get up early tomorrow. But thanks everyone coming along. It was good fun. We did a lot of good work. Grand time was had by all. Next stream will be Wednesday. Model loading. Let's load some models. I need to see what models I've bought and what I'm going to do with them. But other than that, I'll see you all anon.